Hi everyone, and welcome to today's online training session. So my name is Simon Grandin, and I'm the photogrammetry workflow specialist here at SimActive. So today the topic of my presentation will be speeding up drone mapping project. So as much as possible at the end of the presentation, you'll learn some insight on how you can speed up a bit your drone mapping project. We'll cover all the steps you need to do to get the optimal result with Correlator 3D. Also, I will share a bit of tips and experience on every step so you can get the best result out of your own data when you're processing it with Correlator 3D. So let's start about what you will learn during this presentation. So first I will talk about the pre-processing requirements of your drone project. So what you should think of before starting out your photogrammetric processing. Then I will talk about controlling the quality of the input imagery. This has a major impact on the quality of the result you can get. So I'm gonna give you some tips on what to do and what not to do. Also, we'll talk about generating DSM, DTMs, and also 3D models, producing ortho mosaics. Also, I will talk about how you can share and visualize your result on the web. So if you want to share links directly to your customers and they can visualize it throughout Cesium. And then I will finish with some tips for your drone mapping project and how you can improve them with applying some of those tips. At the end of this presentation, we'll have a session of questions. So if you have any questions during this presentation, feel free to write us in the chat, and as much as possible, I will try to answer those questions at the end of the presentation. So first and foremost, the first topic is pre-processing requirements of your photogrammetric data. So it all starts with collecting your drone imagery. Before doing so, you have to think of what is the area you're trying to coverage, what is the project scope you're trying to achieve. This will have an impact on your flying altitude based on your ground simple distance you want to reach with your camera. It's also going to depend on the time you have for delivering your project and also the setup you have for your drone project. Typically, for a drone project, in terms of overlap, we suggest having around 60 to 70% side lap and 70 to 80% front lap. So this is probably the optimal configuration that we recommend for our drone project. It's sure that depending on the type of feature that you're trying to map, those parameters might change a bit. Let's say if you're trying to map a dense forest, well, sometimes raising up the overlap just a bit may help for the 3D reconstruction because you're gonna have more redundancy in your block, and also this redundancy will help to find common features, so tie points between the images, and have a nice reconstruction of your photogrammetric block. Also, in terms of ground simple distance, as much as possible, we want to have something that's constant throughout your project. So if it's possible with your drone during your collection, try as much as possible use a terrain following option. This way, you'll make sure that the ground simple distance will be as much as constant as possible during the collection. If it's not possible and you're trying to map large area, what you can do is you can sometimes split out your block into smaller section, and then derive a flying altitude to have a constant GSD on the whole area. So that's another approach you can use for your drone project. In terms of coverage, you always want to cover more than the area you're trying to map. This way, you'll make sure that on the side of the project, you'll make sure to have enough coverage to have the whole AOI you're trying to have. Also, if you want to have a good absolute accuracy for your project, we suggest using ground control points that are well spread throughout your whole AOI. If also you want to have you don't have the possibility to have ground control points, but you still want to have a good absolute accuracy, you can always use an RTK or a PPK correction for your exterior orientation prior to bring it to in the software. This way, you'll make sure that the input data it's already accurate when you're starting your photogrammetric production. Also, if you're trying to map larger area, it's always better to have larger sensor since it cover more ground in less time. So that's another element to take in mind. Regarding some pre-processing reminder, there's probably maybe 2 or 3 things to do just before you start your large drone project. The first of it is probably make sure that your driver of your graphic card are updated. This way, you'll make sure that you'll get the most out of your GPU, which is really used a lot during our processing. One other thing that's important is before doing all your project, make sure you have enough storage capacity in your on your computer. You also may want to use SSD drive since it should speed up quite well or quite a lot the time processing of your project. If the storage is sometimes an issue or it's limited, we always suggest for the intermediate ortho photos, you can use the JPEG compression. This should really reduce a lot the size of the overall project without compromising any at all the output results that you can get from your drone project. Also, another thing is, well, we have several approach. If you want to break down your project into several computers, if you have access sometimes to many licenses, you can break down different modules into multiple computers. So you can do the AT on your block, and then you can split out DEOs and do the DSM generation on different computers, and then merge it all at the end. So this way, it should faster up your processing time. And at the end, also there's the level of automation you want to reach for your project. So typically, you can run your project from the graphical user interface. But if it's a project or it's project that are repetitively similar, you may want to start scripting out your project. So you may want sometimes run a smaller section on the GUI. And if you're comfortable with the parameters that you have, you can then script out or use the automated workflow to generate a script with your own option, and then directly launch your project from the command prompt without even loaded the graphical user interface. Now that we've talked a bit about the pre-processing requirements, let's talk about how you can control the quality of input imagery. So the photogrammetric process is basically divided into 3 modules. So the first module is the AT module, where most of the accuracy works gets done at this steps. This way, you want to probably cleaning up the input data prior to start your processing. So let's say if your drone has been collecting imagery from as soon as he take off from the ground and until he's going to be taken down at the end of the flight, you probably want to remove the takeoff and landing imagery. Also, if the drone has been taking images while he's turning, you may also want to remove those imagery. You also want to take a look at the quality of the images you have. You don't want to have blurry out images, so that's one thing when you're collecting your drone imagery. Always make sure that before coming back to the office, you have proper settings for your camera. This way, you'll have optimal imagery for your drone project. And also a quick insight on our next release. well, we will have a tool to clean up directly your project within the software. So this will be one great features that that drone project and all other users will probably like within the next release. So as I said, once the cleaning the cleaning input data is done, you should have something like we have here. So parallel flight lines. This way, you'll make sure that all the bad images are removed. This and also this will reduce the processing time of your drone project because you won't have to process imagery that should not be related to your photogrammetric processing. Once you're ready to launch the type point extraction, basically you can launch the type point extraction as a standard option, and then the software will try to retrieve links between all the images. The type point extraction is basically correlated with usually the overlap that you have. So the overlap is really a key factor with the type point extraction, because if you have more overlap, sometimes you'll have more redundancy. So it's always better to have a bit more, but not too much overlap. So let's say you don't want to go higher than 90% because this will lower down your vertical accuracy. But if you're flying difficult areas, maybe 80%, 85% is something reasonable for drone project based on the configuration that you have. So once the type point extraction is done, you maybe want to review the overall links that you have. So you want to have a nice spider web throughout your project. This way, you'll make sure that you have a nice block of images and all your images are tied together. There's not going to be any images that will swing from one side to the other because they will be proper attached to the whole block of images. Then once the type point are extracted, you can also import and tag your ground control points. So this way you'll make sure that you will refine the overall accuracy, absolute accuracy of your model. So as I said before, you want to have your ground control points well spread out throughout your areas of interest. If you're having elevation range in your project, you may want to have ground control points at different elevation if there's a mountainous area. Also, you don't want to have your ground control points too close from the side of the project, because you want them to be seen in multiple imagery. This way, it will have more weight during the bundle adjustment. So once the GCPs are all tagged for your project, you can then run the bundle adjustment. So the bundle adjustment is where we're going to take the initial exterior orientation of the images, the sensor properties, and the ground control points, and we're gonna try to retrieve one model that will allows us to derive all the photogrammetric products such as DSM, DTM, and then Ortho Mosaic 3D models, point cloud. So this way, the quality report that will be provided to you once the bundle adjustment is done will be a key part in the accuracy of your project. So if I jump to the software just to show you quickly how it should look. So basically here you will have this is a smaller project, but it's applying on a larger project as well. So what you would like to have for a typical project is like having a nice spider web here where all the imagery are all linked together as much as possible. This way you won't have any surprise later on in the process. So yeah. One other thing, you can also have checkpoints and ground control points. So basically, the ground control point is used to tie the model to the ground, and the checkpoint is there only to validate the overall project or the overall accuracy of the project. If you want to create some checkpoints, you can either bring in here a text file with the ground control points like this. So I could have here ground control points, and I could either select it as checkpoints, ground control points, vertical, horizontal GCPs. This will assign the same type to all the points. However, if you want to have sometimes maybe different types to specific points, you can go into your project tree, click on the little pencil here, and then you can set the own type to this specific ground control points, and then it will be used as a checkpoint. So when we're gonna do the bundle adjustment, it will use all the ground control points and checkpoints that I will have here. So typically for the bundle adjustment, when you're pressing a large drone project, you would like to use the following parameters. So you would like to let the software compute the EOs or adjust the EOs. You want to let the software calibrate the sensor, and you want to use the ground control points as a ground reference. On top of that, you will have, as we have here, a quality report that will be provided to you. In this case, we had 5 ground control points. So you're gonna have basically a project summary, the numbers of images, the ground control points. Here's the relative assessment, so how well the relative accuracy is in your project. You want to have something that's excellent here, so below 0.75 pixel. Then the bundle parameters that you've used. So there's all sorts of information regarding the aerial triangulation that you have here. So you have the before and after the solution. You will have the overall adjustment that is done on the block. And then here you're gonna have the sensor calibration. And at the end, probably the most relevant, well, the control points analysis. So that's where you want to see that your ground control points fit the overall accuracy that you have for your project. So you want to make sure that the accuracy you achieve here is usually within the specs that you have for your project. Also, one thing that you can do is if maybe you wanna have more information about the overall accuracy of your project, you can take a look in the EAO folder report. There's all sorts of text file that will give you more information about the tie points, the checkpoints, the ground control points. So all the information is stored there, and it's available to the end user if you want to see this kind of outputs. So once the AT is done, well, the rest of the processing should go fairly smoothly if you have a good result of AT. So if you want to process maybe a medium range project, what you can do is you can run probably the AT with the GUI, and then the rest of the project can be run automatically with the automated workflow. So in the software, let's say if you've done your AT, what you can do is once you're satisfied with the AT, you can always run here. You can deselect the AT and then run all the rest from the automated workflow. So once the AT is done, you run this, and then at the end of the day, well, you will have probably your outputs. You can also use the automated workflow to generate some scripts. So that's a good way if you want to start learning how to script with Correlator 3D. Well, you can use the automated workflow to script out your project, or start scripting out your project. Once the AT is done, one great thing is if you're processing a large data set, but you would like to break down your project into smaller sections, you can always disable some flight line. So this will mean that the images will still be in your project, but the image won't be taken in account for the next steps. So let's say I would like to have only a DSM, Ortho, and Mosaic created for the 2 first lines here. So I could go into my project tree here, and then I could retrieve which of those lines should be used. So in this case, it would be flight line 3 and 4. 4 and 3, yeah. And so what I can do, I can select the shift button, And then here, disable the flight line 0, 1, and 3. So I have disabled button here, and they become grayed out. So this means that when I'm going to launch the DSM module, it's only going to be run on this specific section. So now, talking about the DSM generation, this brings me to my second module in Correlator 3D. So if you want to generate surface model, terrain models, and 3D models, there's different elements you want to probably take a look at before. So there's the first thing is for the digital surface model. There's kind of not a competition, but you need to make a choice between the resolution and the processing time you want to achieve. So they're both correlated. So usually, as much as resolution you want to have, the processing time will be a bit higher. So for a typical drone project, we can generate DSMs at around 5 times the ground simple distance. If you want to have highly detailed DTM or DSM, you can use maybe 3 times the ground simple distance, but this will have an effect on the overall processing time. But you should be able to get the best detail possible for your drone project. We suggest not to go lower than 3 times the ground simple distance. Otherwise, you may raise up the processing time too much, and there's not a significant improvement in the quality of the output between 3 to 1 time the ground simple distance. Once the resolution has been done or has been set, let's say if the orthos are your main goals and you're not really careful, or you don't really need a high resolution DSM, you can also raise up the resolution up to 5 to 10 times for orthos. It should be sufficient enough. Also, the vertical accuracy can be set depending on the accuracy you want to reach, and this will give you basically a digital surface model. If you want, you can also derive a point cloud at the same time, but if the point cloud is not mandatory, you can also at the end of the generation, you can export your surface model as a point cloud. So this really reduces the time of processing if you don't need a super dense point cloud, but you want something you would like to have still a point cloud. You can derive a point cloud directly from your DSM with the export as LiDAR point cloud. From the digital surface model, we can then derive a digital terrain model. So we have an algorithm that, as much as possible, remove buildings, cars, trees, and will allows you to auto-rectify your images on the terrain model. So here. What you can do is sometimes this algorithms over a specific features such as bridges may tend to smooth out those areas. So you can use exclusion zones if you want to keep specific features in your terrain model. So the way that it works is basically you can have here your digital surface model. In this case, I would like to keep the stockpiles within the terrain model, so I can either draw exclusion zone with the them editing modules as I have here, or also I can input 3D constraint during the DTM extraction. So let's say if you have known points or break lines that you want to use for the terrain extraction, you can bring them as a feature here, and then use them for the extraction. So in this case, you can bring it into the features and then use them as constraints, and then either elevation constraint or in this case exclusion zone. And as an output, basically you will have something like this. So I still have all the elements removed, so buildings, cars, but I still have intact um, my um, my stockpiles. So let's say if you would like to keep a bridge into your DTM, well, sometimes it can be a good solution to draw to draw an exclusion zone around the bridges or an interchange, and it will be kept intact in the overall digital terrain model. Then we also offer another options. Once the DSM is generated, you can derive 3D meshes from the surface model, which you don't require the orthos and the mosaic. So once the DSM is created, you can launch the 3D generated model, and you have two choices. You can either bring in an existent mesh, so as an OBJ file, and we can use the input imagery to texturize it, or you can use the existent DSM that we have been generated and texturize it um, with the input imagery. The thing with the 3D model is it's highly dependent on the GPU that you have, because most of the viewing software for the 3D model will load the 3D models in cache in memory on the GPU. So the amount of triangles that we'll be able to create for the 3D model will depend on the GPU that you have. So this way, when you create your 3D models, the software will assure and will propose you some sizes that will fit into your GPU configuration. Then you will be able to export it as a OBJ file, and also you can have either the textures in JPEG, which usually takes less amount of space on a disk, or you can have it into a TIFF file if you require highly detailed 3D models. Then once the surface model is done, the terrain model is done, you can then produce your Ortho Mosaic. So basically, the Ortho Mosaic, you have two choices. You can either process orthos from the DSM or from the DTM. So from the DSM, it's something we will call a true ortho. So all the pixel will be rectified from the surface model. And if we produce an ortho from the terrain model, well, it's something we're going to call a classic ortho. So the image will be rectified from the terrain data, but you'll still see some leaning effects or parallax effect on buildings and all elements that are not terrain related. Typically, the classic ortho gives better visual results for mapping product. It's highly depending on the quality of the DTM, but we usually recommend to generate the DTM and then the orthos from the DTM if you want to have great results for your mosaic. So the Ortho Mosaic is basically a two-steps process. First of all, you will need to derive individual ortho from the imagery. So each individual images will have his own file, compressed or not, and then we will take those ortho to derive a seamless and color balance mosaic. So let's say you want to have a smaller or you want to derive a smaller section of your project for the mosaic as some test. So as I said before, you can always disable and re-enable flight line. In this case, if I've disabled those three lines here, it's only going to be the orthos will only be generated from the two flight lines here. So the amount of image that are disabled will not be taken into account for the ortho. However, the mosaic process takes all the image that are that are in the ortho folder. So let's say you want to use specific ortho for your mosaic, but you've already generated all the orthos and you don't want to or to rectify only a smaller part. You can go into the into the ortho folder here, into the ortho section, and you can disable specific ortho. This way, have only a mosaic. Let's say you have rectified all your imagery, and um, you want to have only a mosaic from this section. Well, you can disable all the orthos that are not related to this section, and then you will have a mosaic for this specific section. One thing to notice also is if you want to manage multiple orthos folder, let's say what you can have here is you want to have two ortho folders, two sets of orthos, one for those two lines, and then one for those three lines here. So what you should do is you should derive your surface, your terrain model for the whole project. Then you can disable those three flight lines, generate the orthos from those two lines, and they will appear in your ortho folder here. Once this is done, you want to change here the ortho folders and create a new one that will contain the rest of them. So you want to go here, click on the little plus button. You want to change the folder. Then you would like what you want to do is you want to disable the flight line 3 and 4, and then re-enable the flight line 2 and 1. And then in this new ortho folder that we've just selected, it will contain only those ortho. So this way you can manage multiple sets of ortho in this way. It's the same thing with the mosaic. So let's say you want to compare a true mosaic versus a classic mosaic. It's the same thing. So once every time the process of a mosaic creation is launched, it will be stored in the folder that is specified into the mosaic project tree. So if you want to have multiple mosaic, you might want to change the folder here to get different mosaic and not override them every time. So this way you can manage multiple mosaics. Also, once you have done the orthos and you have launched the overall once you have done the ortho and you have launched your mosaic, here you can also usually for a drone project you can leave those parameters as default. However, if your project is like quite high and you maybe want to limit a bit the seamline editing, if you're in an urban environment, you can select the surface model before launching the DSM generation, the mosaic creation, and use the option loaded DAM for seamline avoidance. So the software, as much as possible, will try to cross the seamlines where we don't have buildings and all sorts of elements. So once the mosaic has been created, you can then derive, or you can then edit the overall seam line. So you can go here and then click on your block, and you can specify like this, and you can edit the overall seam line. Also, if you're managing large project, sometimes it can be the case where you will have many blocks of mosaic. So when I'm talking about blocks here, is basically you can have here I only have one, but for a larger project you can have more than one block. And then if you have a floating license and your project is stored on a server, you can edit different blocks on different computers. On different computers at the same time, which reduce the time that is spent on the seamline editing. Also, you can edit the color of your mosaic, so you can play with the histogram distribution as much as possible. You want to have something that is as a normal distribution So you can play with the range of value. In this case, we have a 8-bit imagery, so it's stored between 0 and 255. But if you have an images that is stored into 16 bits, well, you will see that the range here will change. Will change. Will change in depending on the input imagery. Once this is done and you're satisfied with your mosaic, you can then derive either a single tiles. But for smaller project, this works. But if you're trying to handle larger project, sometimes it's not super nice to give to your customers one big file that is maybe more than 50 gigs if it's a really large project. So you might want to consider tiling the mosaic into smaller section. Um, so if it's the case, um, you can use a fixed style, so you can have a fixed style, or you can import what we typically do. You can also import a shape file that contains your tiles, and if you have an attribute that has the name inside, you will be able to tile your mosaic tiles according to your shape file. So that's one way you can quickly deliver smaller tiles and manage larger mosaics as an output. And it's also easier if you want to do your QT on the GIS software at the end. It's easier if you want to manage smaller um, smaller smaller size. Um, so Also, so once the mosaic is done, one other option that it's not often used, but you can share the result on the cloud. So let's say if you want to probably show the time frame of your project to your end customers, and you want to deliver smaller section, you can always share customized links from Cesium to your customers with your correlator 3D output. So basically, I'm not going to go through in details on how to do it, since we already have a webinar on this topic on our website. But basically, it's a 5 steps, and it's quite easy to do. First of all, you will need to create a Cesium account, and then you can set up your account, so your name and all the information, and then uh, from there you will be able to create tokens. So basically, token here are elements that you will need to have to share and upload data. So once your token are created, you will be able to retrieve it into your Cesium account, and based on the product that you will have in your project tree and has been selected for sharing the results, you will be able to upload the data on the cloud. So let's say here I would like to upload a smaller section. Well, I can select here in this case the DSM, the 3D models, and the mosaic, um, and the mosaic like this. So what I would do is I would go into File, then Share Results, and I would have a window here. So I would have my profile. I would call the name webinar, let's say, and I would select the product I want to upload on the cloud. So mosaic 3D models based on what you have. Here the DM will be the DM that is selected in your project tree. So if for any instance you have the DSM, well, you will have the DSM uploaded to Cesium. And then once you're comfortable with those products, you can then click on process, and well, you will have here a link that will be provided to you. So you will have in the log files. First of all, there's a window that's gonna pop to you, says, do you want to see the results? You can say yes, and then it will bring you directly to Cesium. However, the link is stored also in your log file. So we have the link here, and it will bring you basically here. So I have my Cesium account, and it will bring you to a web browser, and you will be able to visualize here. In this case, it's the 3D model. So um, I will have here the 3D models, and so all I have to do is share this link to the person who would like to see the results, and I would have here the DM. Here in this case, I would have the mosaic also. So if I bring in the mosaic, I could inspect the mosaic, the 3D model, the point cloud also. So all those outputs are stored in your Cesium account. So to wrap those things up and this presentation, let me give you 10 tips to get the most out of your drone project. It's some tips that I've probably talked about during this presentation, but it's gonna be useful tips for your drone project. First of all, it's regarding the plan configure or the data acquisition. Um, so carefully plan your data collection. Make sure you have the proper overlap, proper GSD based on the overall setup that you have. Um, it's so have a proper data collection, since this will have a most impact on your photogrammetric processing. One other thing, clean input data prior to processing. Having a clean data before starting your project will highly reduce your human interaction with the software, since it should reduce the amount of editing you'll need to do for your drone project. Um, if you're processing a larger data set, you may want to validate the overall uh, project on a smaller data sets that is representative of what you're trying to achieve. This way, you can set the optimal parameters on the smaller section, and you can use the automated workflow to script out the rest of your project. And it should be an easier way to process larger data sets. Um, Also, always review the AT result before moving on to the next steps. Specifically the AT, I would say you should review most of the steps, basically the AT and probably the DEM. But the AT is where all the accuracy is getting computed. So you want to make sure that your quality report and your quality report meets the accuracy you need to have for your project, and your block is nicely tied together. You have sufficient GCPs, and so on. Um, Again, select an appropriate resolution for DSM generation. Typically, the DSM takes about 40% of your drone project in processing time. So if at the end the result is you're looking is a mosaic, um, but you don't necessarily need an highly accurate digital surface model, well, probably 3 times the ground sample distance is way too much for your project. You may want to lower that to 5 times, 6 times. Uh, for all orthos and mosaic only, a good rule of thumb is between 5 to 10 times should be good enough for your accurate mosaic. However, if you required a highly dense surface model, well, now you'll need to have the appropriate resolution for your needs. Um, Define exclusion areas for DTM extraction. So let's say if you're seeing your overall project, maybe you want to define exclusion for bridges or for area you want to keep intact into your terrain model. So that's one other thing. Um, if you wanna have optimal processing, or you want to process your project on a smaller section, you can do the 80 on the big block, but then you can disable images or flight lines to process on smaller section. So this is one great features for people that are processing larger project. It's something that usually highly underestimated, but you can disable flight lines, images, and really set the overall areas of interest. A lot of time we have the question, how can I set up a processing extent of my project? Well, by disabling flight line and images, this way it's a good way to achieve your desired section you want to process. Optimize hardware to accelerate processing. Again, here, make sure that your GPU drivers are up to date. You would like to have probably SSD drives if you want to speed up the process a little bit. Make sure that you have enough room or space also. If you're processing similar project throughout the times, start scripting for batch processing. It's probably something that will save you a lot of time. So maybe you want to take a look at some of our webinar we did specifically on scripting. So you can run directly different projects without any human interaction. So the scripting can be done from the project creation up to the deliveries. So everything can be scripted out without even launching the command, the graphical user interface. Also, we offer the possibility to edit the result for deliverables of superior quality at any steps. So you can edit the type points if you want to. You can edit the surface model, the terrain model, the seam lines. So it's all at every step you have the control over your data to get the best result possible. And I would say the last tips, which is one of my favorite. If you have any questions regarding processing, or you wanna manage a large project, feel free to write us an email at sales@simactive.com. We're here to help. So we'll be able to help you out with some project. So again, here quickly, unique benefits. So Correlator 3D it's a tool where you can just crunch massive data sets fairly quickly. It's for different kinds of users. So it can be from the user that will use the automated options, or the user that will try to have as much as possible control on all the parameters. Unlimited numbers of images on a single standard PC. Well, we've managed to process large data sets into a small matter of time. So and also the software can be installed on the cloud. So if you have an AWS or Azure instance, it can be possible, and everything can be run from the command prompt. So if you have script, you want to just crunch out your script, you can all script out your project. Again, we have different licensing options. We have monthly, yearly, permanent subscriptions. We have UAV, medium format, full format, and satellite license available. Also offer node locked or floating license. For marketing purposes, we offer also smaller processing, so around 200 images. And you can also write us at sales@simactive.com, and you can download a free trial from our website, www.simactive.com.